We've seen in previous videos that each individual member of each group has their own particular genetic signature known as their haplotype. And this haplotype for most of the members in genetic family 1 is based on the 37 markers from family tree DNA. One member has had a 111 marker test and another member has had a 67 marker test, but most of the members have just tested to 37 markers. We've also examined the values for each of these markers and have been able to determine the most frequent value, and that has helped us to define the modal haplotype for genetic family 1. And this modal haplotype is probably the unique genetic signature of our most recent common ancestor. So if we go now to look at the ancestors of each of the members in genetic family 1, let's see what we can find. And here we are. Now we can see that here on the left hand side we have the date, and at the bottom all of the members of genetic family 1 lie above the green line. The one member in genetic family 2 lies above the orange line, and the member in genetic family 3 lies above the blue line. The people who have been Y-DNA tested are in the pink squares, and above them you can see each of their Spearin ancestors back as far as their most distant known ancestor. Now, most of the members of this group have been able to trace their ancestors back to about 1800. Before that, there's a gap of about 120 years, and then we pick up the trail again in Limerick with the brothers Hartwell, Mark, Nicholas, and Luke. Now, these were the sons of Luke, who also had a brother Nicholas and Matthew, and they were probably born around about 1665, but again we're not entirely sure. Did Matthew and Nicholas have sons? Well, we know that Matthew had one son called William, but we don't know any of the other members of their family. However, if we assume that there is a 20-year gap between generations, then that would mean that there were 5 or 6 generations between these early Limerick Spearins and the first of our most distant known ancestors. However, an average distance between generations of 33 years is probably more realistic, and so we're probably really looking at only about 3 generations, maybe 4 at the most, between these early Limerick Spearins and the most distant known ancestor of the members of genetic family 1. Before Limerick, there is also a gap. We know a lot about George Spearing, the goldsmith from London in 1558, and we know about his family, including his son George, who was born in 1601 and who married Rebecca Carter. We also know that this George, born in 1601, had a son George, born in 1646. But is this George the father of Matthew, Nicholas, and Luke? Or did George from 1601 have another son, and he is the father of these 3 Spearin brothers? We just don't know at this stage, but further paper-based research may help answer this question. And this is also where genetic genealogy may come to our rescue. Let's turn our attention back to the modal haplotype for genetic family 1. The modal haplotype represents the unique genetic signature of the most recent common ancestor. And on the basis of our documentary research, we would guess that the most recent common ancestor for the members in genetic family 1 is this George Spearing, born in London in 1601. So, in all probability, this George is the most recent common ancestor for this group of people, and he has passed his genetic signature down to each of the members in genetic family 1. Now, of interest, the haplotype of 2 of the members in genetic family 1 is exactly the same as the modal haplotype. So this would suggest that this member here from the Dublin 1 family and also this member here from the New South Wales 1 family, have inherited their haplotype unchanged from George Spearing in 1601. Other members of genetic family 1 have inherited mutations along the way. But the question is, when did these mutations occur? For example, did they occur in the previous generation, or the one before that, or the one before that, or in the most distant known ancestor, or somewhere along the way, going all the way back up to the most recent common ancestor? The mutation could have occurred at any point along this path. There is something we can do to help solve this question, and that is the process of triangulation. For example, if we look at this person here, we see that they have a mutation at CDYB, and that mutation may also be present in other members of this green group. But in order to ascertain that, we should also test his cousin here. Now this person has bought the test, but we're waiting for the results. And if this person was to have exactly the same genetic signature as this person over here, then we could say that these two cousins share the exact genetic signature. We could also conclude that this exactly identical genetic signature has been passed on to them by their most recent common ancestor. And we see that their most recent common ancestor is in fact Tobias, born in 1812. This is the process of triangulation, and it helps us identify the genetic signature of the most recent common ancestor. We could repeat this exercise for Tobias's father, George, born in 1775, by comparing the haplotype of TS, this person here, with the haplotype of one of the descendants of John, born in 1800. If these two haplotypes were exactly the same, then we could reasonably conclude that they had been passed on unchanged from the most recent common ancestor of both these distant cousins, namely George, born in 1775. And in that way we could establish the genetic signature of George. But supposing the haplotype of this descendant of John was different to that of TS, what would we do then? Well, we could find another distant cousin to both of these people, and we could test him. Say, for example, a descendant of James. Now, depending on the results, if the haplotype of James was exactly the same as the haplotype of TS, then we could conclude that the haplotype of George was exactly the same as these two here. If, on the other hand, the haplotype of the descendant of John was exactly the same as TS, or rather of the descendant of James, then we could say that James' descendant and John's descendant shared exactly the same haplotype, and it probably had passed on unchanged from George, and therefore George would share that particular haplotype. So triangulation is a process whereby we're able to identify the genetic signature of the most distant known ancestor. We could also do the same process in the Dublin 1 family. We've already got one member tested. If we tested another member and they had exactly the same genetic signature, we could say that by triangulation, then the genetic signature of Patrick, born in 1802, is probably exactly the same. There are some families, however, where triangulation is not possible. For example, in the family of Luke, where this is the last of the line, and in fact there aren't any cousins to compare this person's haplotype to. The same occurs in the family of Luke, born in 1833. Again, this individual here is the last of the line and has no known cousins which we can compare in terms of their haplotype. So for these particular lines, we just have to assume that the mutation we are seeing in the member that has been tested is also a mutation that has occurred in the most distant known ancestor. But this may be incorrect, because the mutation could have occurred in the generation before the member who was tested, or 2 generations before that, and after the most distant known ancestor. Triangulation allows us to be more accurate about the genetic signature of the most distant known ancestor. And that helps us to be more confident when we come to drawing mutation history trees, which is the subject of the next video.